Welcome to another episode of Thor the Story. Now, here at ElmerRacing, we try to stay a little bit humble and not so boasty, but we also want to absolutely dominate everything we get involved in. So, can we do that in World TimeAttack 2019 in the awesome RP968? Let's find out. So, quick recap for new guys joining in here. 2018 was the first year our Thor engine ran at a race, even completed a full lap at event. It worked, with so many guesstimates in the whole engine, well enough to get the to run perfectly. Well, not perfectly, but run well enough to get the championship at World TimeAttack. So already outperformed all the other engines. But there were some details there that didn't work perfectly, and let's go through those. So on 2018 analysis, let's first start with checking the onboard footage from the fastest lap at 2018. Going here through the final corners here onto the main straight. 100% throttle here. Accelerating quite nicely. Of course, it is with the 4202 turbo, so quite limited on power here. Still topping out 266, really good. Going flat through turn 1. This is the concerning part here. Still flat, but the speed is not increasing there. And that's clearly, well, of course, just looking at throttle position and speed, of course, the track is relatively flat, so there's no like steep uphill or anything like that. But still here you can see like you have a higher speed on the straight, and then after the corner, while it's still flat into turn 2, the speed isn't increasing back to the same level as it was on the straight anymore. So clearly the engine isn't producing the same amount of power there anymore. So that's slightly concerning. That basically means that the cooling system in the engine is not capable of sustaining that power, and that is failing, or well, not really failing, but creating enough issues that you're not making that full amount of power anymore. So in this case, that was publicly said, I think, on some stream or something like that also, and no secret. So there was an exhaust valve that stuck open. That was, I believe, after this run in the next session or something like that. That stuck completely open. So it's fully reasonable to expect that the exhaust valve was not closing fully, and potentially, this was happening on multiple exhaust valves. You have a cylinder pressure leak into the exhaust system basically, and that's reducing power. Then when you come into the corner and off the throttle, then components cool down a little bit, and you regain some movement, and some movement of the exhaust valves, so those start working again and sealing a little bit better. But each time you do that and it starts sticking on the the valve stem starts sticking on the guide, then you run into two problems with that. And of course there can be multiple issues for that. Either the exhaust valve stem is just expanding too much for the valve guide, so that is why it's sticking, or there can be some geometry changes that's creating this sticky issue, or if you have really poorly manufactured valves, those can even like start bending with the temperature. Of course, that was not the case in this engine. And other issues they had in 2018. So we still had the problem with the stepped head gasket. That hadn't created a problem actually in the race, but from the data log, they could see that. So they were running a coolant pressure sensor, which is typically not found in most cars, but in sort of high-end racing cars, that is a very good sensor to have, because it can show potential coolant leaks. And also if you have some method for the combustion pressure to get into the cooling system, which would typically be through the head gasket, but can be a cracked block or cracked cylinder head or something like that also. From that data, they could see that that there was some small pressure fluctuations in the cooling system. So obviously, I mean, having this head gasket that had this step around the cylinder, I mean, you remember this from the previous episode, but yeah, just another recap. So the head gasket that had this step that we hadn't specified was pressing down the cylinder liners into the block once the engine got up to a full operating temperature and running sort of continuous full power at the racetrack. And yeah, so these things moving around a little bit, so that I mean always will create problems for the clamping force distribution. So it wasn't like absolutely 100%. I mean, still good enough to run and probably wouldn't cause any problems, but still something that needs to be solved for the long run. So the RP968 team or the PR Tech team that builds the RP968. So the easiest solution really to work with the components they had, I mean, that I fully agreed with also, was a good way out, was to do these Siamese door linked sleeves basically. So you have, instead of having 4 separate sleeves that limit like what kind of diameter you have, because you have the bores really tightly spaced. So basically had a sort of a mono sleeve where you have 4 separate sleeves but with the top surface in one single piece, and basically have that whole thing pressed into the engine. That means you can run a much wider lip, so you can run this lip. So yeah, you don't have the limit between the sleeves on how wide this can be. So then running a stepped head gasket isn't a problem anymore, because yeah, I mean, the components in that engine are more than strong enough to be able to deal with that sort of a small sort of what is it, unplanned flex or something like that. And yeah, they put that in there, and yeah, ran absolutely fine on the dyno and seemed to look good. So yeah, let's quickly go back for a dyno shot. Yeah, also there was a cooling related issue with the engine. So after disassembling after the 2018 event, yeah, looking at the head at the block, or I mean, yeah, remotely looking at those, so through pictures, of course, from, because yeah, we were back in Finland and they're over in Sydney, so quite a far way away. But yeah, looking at those specifications or the results from the testing, and yeah, some other components. So this is really difficult to explain, because like all of this is, like the exact problems and the solutions for these are absolutely like a secret. I'm not going to say what we did, and not going to show. I mean, we have so good pictures, and like we found a really good solution with some really like quick and super efficient testing to fix that. But unfortunately, I can't say anything about that at all, because yeah, we're still the only company in the world that is capable of making a full billet circuit racing engines with cooling systems that actually work. So I don't want to give any kind of details out to our competitors about yeah, what kind of cooling issue we had, or what the fix was, or how easy that was to do. I mean, it was relatively easy and quick for us to figure that out and look at what to do. But yeah, there were some things to look at on that, definitely. So there was yeah, absolutely every reason to be very, very confident going into 2019. And yeah, especially comparing to 2018, when yeah, speaking with some potential customers and things like that, like, okay, we did win and we were good enough to make an engine right off the bat that will like first try won the World Championship and beat all the other engine packages out there. But still there were some problems with the engine, so that is, I mean, definitely something we want to figure out. But yeah, having like getting the engine package like right off the ball, like off the bat, like with the first guesses good enough to be able to run full power multiple laps, that is like a very, very good indication, because then we know, okay, we're very close. So we know kind of like what kind of a ballpark we might need to move some specifications for to be able to do that sort of on both sort of longer straights potentially, or higher power levels, or more heat, or more laps consecutively, or something like that. So yeah, having actual data and being able to check the components disassembling after that is extremely helpful. So we were super confident going into 2019 that I mean, problems are sorted. I mean, there's always some kind of a little bit of a question mark, because okay, you think you're about here, and yeah, there's like this kind of area where we maybe need to improve, and yeah, you're well like, where's the 0 point? You don't really know, and like, how much do we need to like improve to like be in a safe area for the engine is a little bit of a question mark. But I mean, yeah, having data and being so close, and sort of kind of ballparking, okay, how many percentages do we need to improve on some areas, is a very, very good point to be in for designing engines and doing like small specification tweaks. And this is, of course, so when you're comparing like different engine packages, and yeah, what's the highest power to weight ratio engine, or blah blah blah. So these are, so one of the main things that is very, very important to look at is like comparing apples to apples. If you're comparing like tuned engines to OEM engines, for instance, they're completely different for a new use case. Of course, I mean, if you have a tuned engine that already works for you, then that is, I mean, absolutely fine, and you've basically tested everything and it works, and it's good to go. But for new use cases, going with anything other than an OEM engine is a huge risk, because if there are things that need tweaking on the specifications, then you might be tied down by the components you're using, so that you basically can't, so that you're limited on not being able to make a fix that will cover the issue, whatever that might be. So you might have high torsional loads on the engine because it's a semi-stressed component, or you might have issues with some particular fuels, or oil foaming issues, oil feed issues. You might want to if you're running in a sort of a really, really tightly regulated class, then you might want to be able to really fine-tune small details all over the engine, and potentially reduce frictional losses from camshaft drive systems, or valve train things, or all these kind of different components. So in an OEM engine, I mean, yeah, the sky's the limit. You can change anything you want on that, and you can always make it work, basically, as long as the basic design doesn't have any huge flaws. But on a tuned engine, that's not really possible, because you're going to be limited by the base components you're using, and those can sometimes be very, very limiting. And also, of course, I mean, weight-wise, there's really no other option really than to do, I mean, a full racing engine where you have all the components designed, and okay, if you need to reduce weight from components, you can do that. And yeah, that is really, really happy that we're going forward to with 2019, really showing that this is a big benefit of having an OEM engine, because now, yeah, we can adjust all these small parts, and there are no limits to that. So the most boring part of these events is always the travel stuff. I mean, it's good to travel around and meet people, talk to different people, figure out new business opportunities. I mean, this is all really good. And I mean, sometimes, I mean, it can just be so boring sitting on the planes and like suffering through all the air travel and stuff like that. But then, yeah, sometimes you have absolutely awesome views, and just sit there on the plane, like, yeah, I mean, this is a really nice time to be alive. Like, you can just travel around for business stuff and have these like awesome sunsets, or really nice views over some cities or islands, or yeah, it's just absolutely fantastic. And yeah, of course, the traditional jet lag recovery stop over in Pattaya. I believe when you're in Pattaya, you should have an ice cream at Walking Street or something. Maybe that's just me, I'm not sure. But yeah, so quick stop over there, and then over to World TimeAttack to meet up with the guys again and see what we can come up with this year. Overall expectations for World TimeAttack 2019, I mean, yeah, the live stream, or the what was it, 54 minutes, something like that, recap from the live stream. I mean, absolutely, it says that best. Of course, I'll link to that. But yeah, let's check that out.
What can RP968 do to shake the earth this time at the 2019 World TimeAttack Challenge?
Absolutely. This is a car that is already making moves. Last year it was the overall winner. This year it's set to do that once again. Their off-season development saw some major changes to the suspension setup. We're hoping to see some times that not only set records for World TimeAttack, but the overall world record here for Eastern Crete.
I mean, the Aero package, again, some small fine-tuning on that, so more efficient and higher downforce than previous years, which is always good. But mechanically, yeah, this is one of these sort of bigger changes. So the really rebuilt the front end to get the suspension attachment points stronger, moved the engine. So now they took full advantage of the engine compactness design, so moved that as far down as possible and as far rear as possible also in the engine bay. They previously had a steering rack underneath the engine, so that was limiting how low they could go with that. But yeah, reducing the center of gravity height really helps in like the fast corners, so helps with the outer tire loading, and of course, I mean, helps with the grip levels overall also, so always a benefit to do that. So we did do a custom bell housing design for them for that, so we got the specifications on what kind of length they need, and looked at yeah, they wanted to have that machined over in Australia, so we designed, so looked at what kind of specifications they have for the milling machine over there, and yeah, I did a design for that, ran the FEM programs through that, and tried to guesstimate kind of how much of a torsional load they will run through that, because they had the engine rigidly mounted from the rear and through the engine mounts now, so they help support the suspension a little bit. So yeah, tried to estimate a little bit at what kind of torsional loading there might be there, and yeah, did the design to help with that. And yeah, I can, yeah, so spoiler alert, but yeah, that part worked absolutely fine, and yeah, they were able to manufacture that, so super happy with that. Other modifications, what do I have on the list here? Oh yeah, so they changed the turbocharger from the Garrett 4202, I believe it was, they were using previous year, where the back pressure was really getting high, and they were absolutely maxing out the compressor side also, so it was a really small turbo for that engine. But yeah, for 2019 they moved over to the G42-1450, so Garrett recommends that for up to 1450 horsepower, and yeah, much better turbo. I was a little bit concerned about the turbine section, because Garrett still doesn't provide the flow rating for the different turbine AR sections they have there, just have like a single curve. I'm like, well, which of the ARs is this actually for? I mean, I think probably, yeah, it would probably be possible to get that information from Garrett, but I mean, yeah, we didn't really have that. But I mean, yeah, I mean, it's probably a much better turbo than the 4202, so yeah, really happy with that. And yeah, they went forward with that. What else? Engine moved, yeah. Oh yeah, and again, so testing issue. You would think that, yeah, the engine package is really well sorted, but they actually did quite a significant amount of sort of mechanical rebuilding on that car, and reducing weight also, so they were a little bit overweight. I mean, even with the weight reduction, or the mass reduction from the lighter weight engine, but the overall components on the car were still reasonably heavy, so they saved some more mass there, and they got that distributed much better. So that was a big benefit. What else? Yeah, and because of all of that, all of those changes, and again, nothing like helps progress as much as a quickly approaching deadline. So they basically ended up, yeah, only testing on, I believe it was only testing on the Thursday again before the race. But I mean, again, super professional team that actually know what they're doing, and we hopefully know what we're doing with the engine. And yeah, what recommendations we had for that. So yeah, still even with almost no testing, really happy going into the event. But yeah, so Thursday testing session. yeah, tire problems was the main issue. So temperatures were much higher in 2019, and it was dry. I mean, dry is of course good for traction, but higher temperatures is not really that good, because the tire flex, so both the internal flex and the slippage of the rubber traction surface in relation to the asphalt, all of that creates heat. And the main cooling that the tire has is the contact patch with the road surface. So if the road surface temperature goes up, that means because you're limited at some maximum temperature at the tire, so then you have a smaller temperature delta that you can run through that tire, and that of course means that smaller delta temperature allows a smaller amount of energy per time unit, so a smaller amount of power that can be transferred through that tire. So you want to have very, very cool temperatures, and then you can transfer more power through the tire, and that means you can take high-speed corners faster. You can put in more power on the straights and without the tire overheating. Of course, there are other ways that tire can fail also, but yeah, this is one of the main issues. So they did have one tire failure on Thursday, but luckily the aerodynamic package on the RP968 is really stiffly built up, and the parts around the wheel wall are really really strong, so that didn't end up damaging the car too much, so they were able to just rebuild that and get ready for Friday racing. Engine wise, it seemed to work really well. They were having a problem, engine related problem though, so in lower gears, even with the wastegate fully open, they weren't able to get the boost pressure down low enough, so they were having traction problems in the lower gears. And so a fix for that race, so during the race, was basically to start using the blow-off valve a little bit to help alleviate that problem. So this is something you typically don't see, because this is like issues only with very, very high power cars, where you need to be able to run full throttle pedal, or typically want to run a full throttle pedal at lower speeds, but have sort of a lower maximum power output from the engine. So you want to reduce the boost pressure at lower speeds, for instance, so in gears 1 through 2 or whatever that would be in different racing classes. And this is something we see in some race classes, so and in some uses. So we have a solution for that here at ElmerRacing. So the billet collectors we make typically have a wastegate exit, to reduce costs, so they're more economical for customers. Just have a wastegate off the side, and that is okay for probably 95-99% of use cases, something like that. But in use cases where you really need to be able to achieve very low boost pressures with turbochargers that are designed for maximum power, so that means that very low exhaust back pressures, you start building boost already. And then one of the solutions for that is this type of a selection. So this type of a case, so we have these with or without like integrated wastegate or integrated V-bands. So you would have a collector set up like this, and a bend. So this is especially on the drag racing cars where you have huge turbochargers that won't fit like in some specific angle, and you need to have like these more elaborate solutions. So then you can have sort of that the exhaust gas flow sort of wants to press out into the wastegate partly, and then you can adjust with the wastegate very, very low boost pressures without having a problem. And we do this with the collectors also. So we have some special designs where these inlets are angled over to a side, and then we have the wastegate exit on this side here. We didn't have, unfortunately, any of those in stock at the moment, so I can't show that to you guys. For some special cases we do have solutions for that. At the racetrack they basically just mapped in a little bit of a blow-off valve opening there to help limit the boost pressure at lower gears, and they did manage to get that to work. This is also something we are working here, so a little bit sidetracking, but with our XM's control electronics that we're developing, thinking about something like that will be on our ER8 race car, for instance, and we're in some interesting discussions about that also, maybe that in some later videos, guys. So power management system that we have in that. So it's not just a power management system, but a real-time power management system that should theoretically be capable of these kind of failures. Like, okay, like if one component is like maxing out the sort of usage range, but the engine is still making more power than what you're commanding from it, then it can adjust other parameters also, and depending on what kind of settings you have in that power management system, you can even run cylinder cuts or throttle valve closing or ignition retarder or things like this, of course taking other parameters into consideration also. So that is, for instance, something that could potentially deal with something like this in real time also without needing to do retuning. But I mean, yeah, this is of course state-of-the-art stuff that isn't in any conventional ECUs at the moment. So not something that you can use at the moment. But excellent workaround from the team to use that blow-off valve. So we're looking good with the RP968 and the Thor engine going into the race on Friday. And conditions were relatively hot. The weather forecast for Saturday was much better, so we're expecting the lap times on Saturday to improve. But still, I mean, wanted to use Friday to get as fast a lap as possible, because I mean, you never know, weather can change, engines can explode, whatever can happen. You use that for testing and adjusting the car, and things were looking good. But then, huge drama.
That power down from here. Let's go on board and have a little bit of a listen to 4 litres of billet 4-cylinder down the main straight here. Slight roll off through Armando, and look at that, a little bit of drama early on there for RP968. Pulling over after that flying lap, and a little bit of smoke out from under the bonnet. I hope that's not too critical. But Moy, still minute 22.14. Andre Heimgartner in the Hammerhead, minute 22.662.
So seeing that happen, oh man, yeah. Remember being up on the roof on the pit garage there, seeing Bart pull over, heard from the, I don't believe it was with Rod probably there listening in on the radio that there was smoke coming out of the engine bay there, and had the just lose all power on the car. So that was like, okay, like maybe the engine didn't really work well. Did we make some situation worse? Maybe, like, that would seem extremely unlikely, but yeah, maybe put a connecting rod through the block or something. But I mean, like a bearing failure or oil, like, which would mean oiling failure, or like what was really going on there? And that was super bad situation. So I headed down to the pits and tried to get some information on what happened. But no one really knew much about that. But I got the car pulled back in, so I didn't really have any damage on that, and the guys pulled off the hood there, and luckily it wasn't sort of kind of a non-issue. So wastegate exit pipe, I believe they had like a flex piece or something in there, and that was just too thin, so that had broken off, and the exhaust pipe from the wastegate had just basically been blowing in exhaust gas into the engine bay, and that had ended up burning through the insulation from a wire to the power distribution unit, and that had cut engine power completely. So luckily there was no fire on the car or anything like that, and a very easy fix. Just replace that one wire, and the guys welded in a new wastegate pipe. So that was sort of a really close call, or not a close call technically, but sort of emotionally a really close call. Like oh crap! Like, is our absolutely perfect engine that we're reasonably sure should work, like that has like let go in a big way, and like yet another one of the sort of engine failures there, like, and that is like, only Friday and still 1 day left, like someone could potentially take the title away or something like that. But nah, I mean, all was good. So really happy after Friday, and really looking forward to Saturday. So Saturday, temperature is looking better than Friday, definitely. The wind is not as gusty, but still reasonably high gusty wind. And that's not ideal for cornering speed, because if you suddenly have a 40 km/h wind like in the same direction you're traveling, you lose a huge amount of downforce, and then you can't go as fast through the corner. And yeah, that's a big problem, of course. But yeah, let's again watch the live stream recap for Barton's lap.
Do better than a minute 19.82 that he ran last year. Here we are on Saturday, prime conditions. Oh, that's nearly flat through Armando.
Incredible footage, isn't it, Chris?
Oh, he knows his way around this track, Barton. And look, all that tuning they were talking about doing on Friday, here it is on Saturday, as we say, the big dads. Flat through there. Paddle shift down. I mean, the car's absolutely an amazing vehicle. You've got to take your hats off to Barton Moy. He knows how to get this beast around the place. Oh, look, Garth Wallen there on the inside there, just getting out of the way. So was Alex Danielson, so he's still on a fly here.
It really does give you a scope of how fast, incredibly fast this car is when you see the in-car, doesn't it, Chris?
Yes, comes out of turn 8 nice and clean now. Look, minute 19.82 was last year. What can he do there? It's been a fairly clean lap here for Barton, taking up all the space that he needs. As Ian Baker said, he's got the dials turned to 11, all that, well, probably 1,500 plus horsepower if you've got it really wound out, that billet 4-litre. Comes across the line there, looks fantastic. Oh, yes, it is. Minute 19.277 for Barton, and only by a tenth missing out on the complete outright lap record.
So a big improvement in lap time again. And yeah, especially considering the conditions, that was really good. I mean, again, it's dry, but high track temperatures, so you can't run the tires as hard. And yeah, it's starting to really reach the limit of the tires, so track temperature helps hugely with lap time. But yeah, if we look at the lap times compared to 2018, so a good improvement. Still just a tiny fraction away from the absolute lap record. But yeah, conditions were expected to be better at the superlap, and there was maybe even the possibility of a light drizzle or something to really cool down the track surface temperature, which would be really beneficial. And yeah, the guys were also tweaking the suspension setup a little bit, tuning the aerodynamic balance a little bit on the car, and actually being able to do some adjustments. So yeah, we were really positive and hoping for the best for superlap.
Yeah, and you know what? That was, you just saw the whole Coot family in the shot there. They're still a very tight family-run team with, just helped by friends, and it's quite remarkable what they can do.
All right, here he is, the man that is on top of the podium again in 2019. Maximum attack through Armando. Oh, he's fearless in that car. That is an absolute landlocked missile. Now there's an ultimate goal here. Can he be the fastest vehicle around Sydney Motorsport Park on this lap? He's just got to go minute 19.1 something. He's only got to get another tenth off what he's run with the minute 19.27 before.
Don't these cars with all the sparks flying out remind you of the old F1 days? It's quite remarkable, isn't it?
Oh, it's incredible just how much downforce is on display here. Horsepower as well. I mean, this big billet 4-litre engine designed and built in Finland. Here it is in RP968. Undoubtedly the world's baddest time attack car.
And when you ask Bart, so what's it like to drive, Bart, he said, mate, it's insane.
And when you ask the owner, Rob Poperstek, what was the whole mission about this car, he said, I wanted something cool, I wanted something fast. Well, you can tick all those boxes. RP968 is indeed that, and an undisputed world champion.
He's certainly a visionary, Rob Poperstek, doing this project. He's guided the thing the whole way through, and it really is a credit to him and everyone involved in it. Sammy Diasonis, the aerodynamicist, Bjorn, the suspension tech, and all the guys at PR Technology, and yeah, it's just incredible.
Here comes the last flying lap of the event for Barton. He goes minute 19.90. So couldn't quite wrap a few tenths up there, but you know what? These conditions, that's still damn impressive. Minute 19 anything at Sydney Motorsport Park. You've seen something fast. The tail of the tape for Royal Purple Pro Class 2019.
Ooh, really fast lap time. I mean, yeah, nothing to sneeze at all. I mean, really fast lap time that would have been enough to win the event also, but not fast enough to take the absolute lap record. So that was kind of a bummer. But looking at that, so the track was a little bit too damp. I mean, it shouldn't necessarily be a problem directly, But again, I mean, being at the absolute limit of the tires, I mean, track temperature and dampness and all of this affects that hugely. So looking back at the different sessions during that event, definitely have one clear reason, because I don't remember what turn it was, but Barton said that I think there were a few corners that he said that were a little bit slippier than what he expected, and lost some time in those corners. So yeah, looking back at the event and how that happened, the Revline Racing Porsche 968 that was racing there also, so both in Pro Class and Pro-Am. So Pro Class is the top class where the RP 968 races. And they had done some really good lap times and got the maximum out of that car, and decided to really push the engine to maximum power output levels. And I think they were targeting or running a boost target level that would put them at about 1,000 horsepower or something like that. And they had a changed head gasket previously, and had some fluctuations in oil pressure or something, so they were really at the limit there of that engine. Unfortunately, they had split the engine block at the crankcase there, so I mean, they had exceeded the capability of that stock engine at about 1,000 horsepower, something like that. And that had ended up, my guess is probably ended up like spreading out a little bit of oil onto the track, and with the sort of light rain there, that sort of brings that small amount of oil up to the surface and makes that track just a little bit slippier. I have no idea. I can't speak English anymore. Anyway, you guys know what I'm talking about. And that was probably the factor that prevented the Rod and the RP968 with Barton from taking the absolute lap record there on super lap. I mean, of course, it's speculation always, and you can always speculate, and there are always reasons, but I think that's probably sort of the main package really that made that happen, unfortunately. But I mean, it also provides a reasonably good sort of comparison. So I mean, the Porsche engine that is in that 968 from factory is a really good designed engine. So it's really large displacement, has good cooling. It's really absolutely, at the time I would guess that's definitely state-of-the-art stuff. So really thin wall aluminum structures there to save weight on the engine package, and it's a really lightweight engine from the factory, and it's really strong and will hold up to really high engine powers. But with our OEM racing version, that shares some dimensions with that engine. I think the maximum power output that they took from that on the RP968 was about 1,350 horsepower, something like that from the engine. And that is, again, I mean, they're tire limited. So if you take more power out of the engine, then you go faster on the straight, and then you have more downforce that presses down on the tires harder. And if you've followed our ERA, the Tech series, you will know that ends up crumpling the sidewalls of the tires heavier, and that will end up destroying the tires, unfortunately. So in high gears you can't run full power because you will end up destroying the tires, and in low gears you can't run full power because you're limited by the traction amount. So there's like, theoretically, maybe in fourth or fifth gear you could run more power, but you're sort of getting to sort of diminishing returns on how much power you could really use. So I mean, basically our Thor engine is too powerful for the RP968 really, and that's, I mean, an extreme car, but interesting stuff. And that engine, I mean, it is not really at the maximum sort of capability at all at that. I mean, even at 1,500 horsepower that I rate that for, it's not at maximum. And that factory Porsche engine that is heavier and can't take that power failed at what was that, about realistically probably around 850-900 horsepower, something like that, and fails after a single lap at about 1,000 horsepower. But interesting comparisons. So super nice event. Really a lot of things to analyze. So time to get on a plane, fly back over to Finland, and of course take a jet lag compensation stopover in Thailand again. So headed back over to Pattaya, and have some nice airplane and some beach pictures maybe for you in the video here. Unfortunately, yeah, we don't have any girl pictures that would not result in this video being banned from YouTube, so you'll just have to use your imagination for those. But yeah, back in Finland, so yeah, let's start analyzing the results on the engine. So the lap times are, of course, yeah, very quick to analyze here once we're back in Finland. Have lots of time here at our shop, or well, lots of time is maybe a bad term, but yeah, you probably understand what I mean. Yeah, so looking over here, jumping over to 2019, so the improvement curve, yeah, definitely hit a limit there. So I mean, the tires were really maxing out the tires on that, and of course that's the yeah, Rod and the RP968 team over, yeah, PR Tech guys that are working on that. So not something we directly do with the Thor engine relating to the tire, but we're starting sort of to reach a performance plateau there. There's probably half a second, 1 second maybe still in the car, I would guess, with those tires, but maybe a little bit more if you get absolutely perfect conditions. Really difficult to say. But yeah, the most impressive thing here is seeing that the gap to the second fastest car. So the conditions, again, even though the conditions in 2018 weren't as good as in 2017, in 2019 they were actually worse. So the second fastest car actually wound up running slower than in 2018. And yeah, with the RP968 with the Thor engine updates, yeah, we've managed to pull off a faster lap time. So really impressive. So the updates, did they work? Well, this is a yeah, relatively easy question to answer. So the absolutely 100% secret cooling system related things, yeah, no problem at all. Engine was absolutely flawless, no issues with that at all during the race. Yeah, we did some clearance modifications to the exhaust valves. Those ran absolutely flawless, no leakage issues with those at all due to any kind of large clearances or anything like that. So well within the tolerance ranges where you can run on the valve stem seals and stuff like that. So really perfect for that. And the yeah, solution for running the stepped head gasket that the PR Tech team yeah, came up with that, absolutely no problems with that. I mean, I would have been extremely surprised if that would have created problems. So, and it didn't create any problems, so really happy with that also. So that basically means that yeah, the engine is flawless, can run a race event without any issues at all, can run more race events also. So really happy with that, and can finally sort of claim in 2018 we did have the highest power to mass ratio OEM circuit racing engine ever, and it was good enough to take a world championship title. So we can definitely claim that it has run at one event at the sort of, but yeah, not really at the power level at 1,500 horsepower, so a little bit of a question mark. But after 2019 definitely can claim that. So 1,500 horsepower will do that absolutely without a problem, and we ran up to 1,300 horsepower there with zero issues. And yeah, having that data and comparing that data from the what we had the runs from 2018 and the disassembly of the engine, and looking at those components, I mean, absolutely confident in saying that the engine is capable of running 1,500 horsepower. Yeah, mass is really good on that. So yeah, with a complete engine package, so turbochargers also included, which you of course have to do to compare normally aspirated engines to turbocharged engines. So yeah, better power to mass ratio than the yeah, F1 V10 Honda engine. I believe that was the previous record holder for the best circuit racing OEM engine. So really happy to be sort of firmly taking that title. What else was there? Yeah, and of course, yeah, how easy to use. I mean, especially considering how easy to use that Thor engine is. So yeah, I mean, as you heard here, I mean, the custom exhaust manifold you've built for your car had some problems or something. I mean, the engine is more than flexible enough, so you can just start opening blow-off valves or something like that to tune your engine if your wastegate system isn't capable of that, or if you have a really advanced system or running XMs or something like that and have a component fail, then theoretically it will be capable of compensating for that in real time on the track without any sort of tuner intervention at all. So yeah, really easy to use engine, and also very compact. So it takes up very little space in the engine bay. So you can run that. You can like replace big V12 engines or something like that, and probably have better power off boost, and yeah, much higher sort of compactness and power mass ratio than with yeah, any current engines. So really happy about the outcome of 2019. And yeah, so knowing that the bill housing also held up fine. Of course, the engine we weren't really concerned about the sort of semi-stressed nature or not, because yeah, we have run calculations for that previously, and that's very stiff. I mean, we've designed that with the cylinder head clamping also, so that provides additional sort of rigidity to that whole engine package. And but yeah, having run that actually on the RP968, a really extreme high performance car, running with the engine as a semi-stressed member, so not bearing the full load from the front suspension, but part of the loads from the front suspension. And yeah, having zero issues with that, which we were expecting, but now we have confirmation from that also. So really nice for that. So also seeing the engine inspection option being yeah, in use was really nice. So yeah, after Friday they yeah, pulled out the connecting rod big end bearings there and inspected those to see like, yeah, are we safe? Do we need to like change over the connecting rods or not? Because again, this was drag racing connecting rods, which theoretically have a very limited lifespan, but that depends on how much RPM, and this is kind of a special use case, so no one really knows. But yeah, we're able to pull that out and check. Okay, like the engine looks absolutely fresh. There are no tiny cracks in the connecting rods at all. Bearings look absolutely perfect, so no problem with increasing the power levels for Saturday. And yeah, we're joking around with the guys, comparing like, okay, yeah, if you try to do this on a GTR or something like that, that's probably like a 10-hour job. And yeah, with our Thor engine, if you don't have any components underneath the engine like super close, so that you can remove the service hatch there, it's a 5-minute job. So yeah, something you can actually feasible do, and inspect things and see how much further you want to push stuff. So really happy that actually worked and was a big benefit. So that was it for this episode of our Thor the Story. This was World TimeAttack 2019, and we stomped on the opposition. Absolutely perfect. And yeah, next episode, that's going to be a mystery episode. And by mystery, we mean that we don't even know what's going to be a next episode. So you guys will just have to tune in and see what happens. That's coming out next Friday, so 3/7/2020. What is it? June, so July 3rd. And stay tuned for that one. So nothing left but to say that I'm Oscar from ElmerRacing, and see you guys in the next one.